Nakamoto contributes to construct a new purification plant by Ecological Purification System for the National Hospital in Hyderabad, Jamshedpur, Pakistan. This is a JICA project. This project is not completed. I got a permission to inform this system for the JICA training. There is the infrastructure survey report in 2019. We can understand the background of this purification plant for the university hospital by this report. There is dry period and rainy period in Hyderabad. And very hot summer. Water source for Liquid University Complex is surface water of Karachi Canal which comes from Indus River. At first, settling basins, and the rapid sand filter plant. The treated water is supplied to University Hospital. JICA project is to build new hospital building and water treatment system for this new building. One of the problem is that the water to hospital building is supplied for only 4 hours daily from 8 a.m. to 12 a.m. from the overhead water tank. This means the filter plant works during this 4 hours. And the water pump works also same time. This is only 4 hours. The big problem is that neither chlorination nor any type of disinfection is done in this plant and merely alum is used for silt settlement. And the operating time of pump to the overhead tanks between 4 to 5 hours daily. This water is suppled to the hospital building for 4 hours from 8 a.m. to 12 a.m. using natural gravity. The water quality is not good for the hospital use. Further purification is necessary to medical use. RO membrane system is necessary for the medical purpose. New build-int for this hospital and new water treatment system were proposed by JICA project. Watching the Google map in June 2025. Proposed building is already almost completed. However, proposed water treatment plant and storage tank are not yet constructed. This is outline of flow system of proposed water treatment plant and storage tank. Design capacity of plant is 50 tons daily for new building. There is measuring unit. 2 steps of upflow roughing filter. And slow sand filter. And reservoir. This filter rate of sand filter is 3.2 meter per day. However, English standard rate is 4.8 meter per day. And present Thames rate is 12 meter per day. Biological activity is very high in warm region in comparison with England. We will suppose more high flow rate is acceptable. There are 2 set of filtration system for maintenance. Each URF is 1.6 meter width, 2.8 meter length and 3.6 meter depth. Upper small gravel layette is 2.85 meter. And lower large gravel layer. The flow rate is 5.4 meter per day. Area of slow sand filter is almost double. There is upper small sand layer with 1.2 meter depth. Mosquito mesh placed between sand layer and support gravel layer. Decigen flow rate is 3.2 meter per day. The raw water was a little turbid, but because it had not been disinfected with chlorine, it was able to support biological communities. The turbidity formed on the surface of the URF gravel, so the water that passed through the URF was clear. Green algae had grown on the gravel and peeled off, floating to the surface of the water. When the gravel was removed, a string-like nest was found, which was the nest of a predatory midge. 3 months later, in June, the turbidity of the raw water had increased considerably. The water above the first URF was a little turbid. But the water that had passed through the second URF was clear. It seemed that the turbidity was caused by the gravel layer in the URF. After all, the 2-stage URF seemed to be the best. The gravel in the URF is large, so it doesn't clog. Algae were growing on the gravel in the URF and on the sand layer in the SSF. 11 days later, the turbidity of the raw water had increased even more. However, the turbidity of the water above the first URF had decreased and become clearer. Furthermore, algae were actively growing on the gravel. It was believed that the algae were growing well because microscopic animals in the URF broke down the turbidity in the raw water, increasing the amount of nutrients. The algae growth above the second URF and SSF seemed to be good. To confirm this condition, I asked the on-site engineer to get closer and take photos. Algae were thriving on the gravel of the first URF. The condition was the same on the second URF. We could see that the algae were growing well on the SSF. In this purification system, we could see that the algae were growing well and the decomposition of microscopic animals was active, and that the biological community was active. It was good that the gravel layer was sufficiently thick, and the sand layer was also sufficiently thick. This is truly an ecological purification system. There is heavy rainfall in hot summer. High turbid water comes. Treated turbid water after existing filtration plant comes to this ecological purification system. The raw water to this new ecological purification system comes during 4 hours from 8 a.m. from existing purification plant. This water is turbid water. There are 2 steps of upflow roughing filter and slow sand filter. URF is artificially to make clear subsurface water in a floodplain. Periodical drain of accumulated bottom mud from URF. However, this URF may not clog due to large gravel. It is better to drain some part of the accumulated mud once a year after rain period. That is in October. There are important biological communities to trap and decompose mud in raw water. SSF may not clog due to high biological acidity like natural spring. If the dirt on the sand becomes too thick, use a rake to remove it. If aquatic plants grow in the sand tank, remove them. Constant flow. When dry and re-wetting condition or a sudden change of water quality attack to this site, biological organisms escape to deep layer. Escaped organisms become a resting form. Living organisms has an ability to escape from risks. Snail survives during dry period. When rain comes, snail move around quickly. Anhydrobiosis and cryptobiosis phenomena are common in nature. Organisms, especially aquatic small organisms, have a strong ability to tolerate and escape the severe period. The lifespan of microorganisms is short. Their adaptability is high. They can tolerate severe period. In case of this plant, the raw water comes 4 hours every day. This condition may not be severe condition. Dry and re-wetting. If some unexpected sudden change of water quality or interruption of inflow water, grazing animals escape to deep layer from the surface where is more gentle and safe condition to survive. Some turbid matter passes the surface to deep layer. And this passed matter adheres to the surface of sand. This phenomenon occurs in soil. Rainfall is not constant. Penetrated rain drops flow slowly into deep place. In case of EPS, interruption of water flow happened, then the surface nearly dried up. After dry condition, it takes time restart and redevelop an active healthy ecosystem. Before restart the ecosystem, some impurities may leak through the system. When water flow stopped, small organisms on the surface escape from the top into gravel layer. And some particles are not trapped by small organisms. In case of sand filter, small organisms escape from the top into deep sand layer. In case of this plant, the raw water comes only 4 hours every day. There are enough depth of adhere gravel layer and sand layer. This condition may not be sever condition. Oxygen, making it easier for animals to thrive. The activity of microorganisms and animals is related to temperature. Hungry microscopic animals will eat anything. This is ecological purification system. Key is gentle for any small organisms. I contributed to built water supply plant to the National Ratnapura Hospital in Sri Lanka by EPS. The capacity of this plant is 140 tons per day. I explained the chemical-free mechanism of EPS, the maintenance and management of EPS at the site to the engineers in January 2001. This was wise use of natural system. The manager understood the reason that we had commercial technology. I visited again this site after construction in 10 years later. The hospital director said there was no problem. Ecological Purification System, EPS, this is wise use of natural phenomena. This is chemical-free system to make artificial delicious spring water. This is a smart and eco-friendly technique. Key is gentle for small organisms. We can make EPS purification device by ourselves. EPS from Japan to the world. Wise use of natural phenomena for human life. Safe and delicious water by EPS, our technology. Trust our sense. Super clean delicious water. Remember 3 steps. 1. Knowing is not enough, we must apply. it to something useful. 2. Willingness is not enough, we must put it into the plan and action. 3. Putting the plan into action is not enough. We must accomplish the goals.